Okay. Also, we will be seeing the advantages and disadvantages of Bresenham algorithm. Okay. So we'll start with introduction to Bresenham algorithm. Now this algorithm is used for scan converting a line. Now in the very first lecture, I have already explained what is scan converting a line. Okay, I'll explain it again. Scan converting means every graphical object that you are drawing onto the screen, be it a line or ellipse or circle, any graphical object that you are drawing onto the screen, that object is made up of number of points. Each of those points are then converted into corresponding pixels. Okay, so scan converting a line means what? A line is made up of number of points. All those points are converted into corresponding pixels. Okay, then this algorithm was developed by Bresenham. So he was the one who had created the algorithm, and he has given his name. This algorithm attempts to generate the points between the starting and ending coordinates. So in the numerical, starting and ending coordinates would be given to you. You have to find out what will be the points that would lie between the starting and ending coordinates. Okay. Now again, this is a very simple and very efficient method because not much of the complex operations you will be performing. A very simple mathematical operations like addition, subtraction and multiplication operation you are going to perform. Okay, so that is why it's quite simple algorithm. Now in this method, how the next pixel would be chosen. Generally the next pixel is chosen based on how close that particular point is to the line. Okay, so basically how the point is closer or nearby to the line, that particular point a pixel is chosen. Okay, now just look at the diagram over here. In this particular diagram, there is a starting point which is already given to you. Okay, so the starting point of this particular line is what? It is 2 comma 3. Okay, so this 2 comma 3, it is given the naming as x of k comma y of k. 2 is what? It is the vertical line, the point on the vertical line, and 3 is what? It is the point on the, sorry, 2 is the point on the horizontal line and 3 is the point on the vertical line. Okay, so the naming given over here is x of k comma y of k. Okay, so this is the starting point of a line. Now to this particular starting point, there are two nearest point which are there in the graph. Okay, so two nearest point are what? Those are 3 comma 3. Okay, and 3 comma 4. These are the nearest point. Okay, so how those points are evaluated? So first, if we see the first nearby pixel, which is 3 comma 3. So how it is obtained? It is obtained by you're adding 1 to the x coordinate. Okay, and y will remain as it is. So that's how you form x of k plus 1 comma y of k. Okay, so initially x coordinate value was how much? It was 2, but having x coordinate as 3. Okay, so how you will evaluate? You will evaluate as x of k plus 1 and y will remain as it is. Similarly, for the other pixel, which is 3 comma 4, how 3 comma 4 is evaluated? Then the earlier x coordinate value is how much? It is 2. Okay, and the nearby pixel is having the value as 3. So just add 1 into the previous x coordinate, and the y coordinate is having the value as 4. Okay, so just add 1 into the previous y coordinate. So that's how you obtain x of k plus 1 and y of k plus 1. Okay, so for the starting point, you have got two nearby pixel. Now over here, the question is, which is the nearby pixel you have to choose? Okay, which is the nearby pixel you would choose? So for that, you would require a decision parameter. Okay, you would require a decision parameter which is specified with the naming as p of k. Okay, which is specified with a naming as p of k. So depending upon this near decision parameter, you will decide which pixel you are going to choose for generating a line. Okay, now again, over here, the condition, the as you can see from the diagram over here, there is a straight line which is drawn. Now, this straight line is passing through a point. It is already passing through a point. For that particular point, there are two nearby pixels. The one pixel is above that particular line, and another pixel is below that particular line. Okay, so the pixel which is above, you can name it as D upper, and the pixel which is below the line, you name it as D lower. Okay, so if your decision parameter is negative, that is, if P of K is negative, then you will choose a lower pixel. Okay. Otherwise, you would choose the upper pixel, which is D of upper. Okay. So this decision parameter will help you to find out which is the nearby pixel you have to choose. Now the question is, what is the formula that is used to compute decision parameter? So we will see in the next slide. So to compute P of K, the formula is 2 of delta Y minus delta X. Okay, so this is the formula that you are going to apply to compute the decision parameter. So delta Y, you already know how you compute it. Mod of y2 minus y1, and delta x, how you compute? Mod of x2 minus x1. So already you know the formula of delta y and delta x. Okay, simply you use this particular formula and you compute the decision parameter. Now once you obtain the decision parameter, there are two conditions that will be generated. Okay, so what will be the two conditions? Now over here, if your decision parameter is less than 0, that means if you obtain negative value, okay, if you obtain negative decision parameter, how the x and y values would be computed? Along with that, you will also have to compute what will be the next decision parameter. Okay, so three things you will be computing. So if your decision parameter is less than 0, that is negative value, then the first thing you will compute is decision parameter for the next point. Okay, so it will be the previous decision parameter plus 2 delta y. Okay, then once you have obtained the next decision parameter, then you have to obtain the next x value and next y value. So next x value, how you will obtain? It will be, you are just going to add 1 in the previous x value, and for the y coordinate, how you are going to do? The y coordinate value will remain as it is. Okay, so there will not be any operation that you will perform for y coordinate. Then if your decision parameter is greater than or equal to 0, that means if the decision parameter is 0 or any positive integer value, then how you will compute the decision parameter and new x and y values? So for that, the formula is, for decision parameter, it will be previous decision parameter plus 2 delta y minus 2 delta x. Okay, so this will be the next decision parameter. And for x and y value, how you will compute? Simply you will add 1 to both x and y values. Okay, so this is how x y values are computed and next decision parameters are computed. Understood this? So far, any doubt in this? Any doubt, students? Okay, okay. So till here we have seen how the Bresenham algorithm works. It is totally working on the decision parameter. Okay, and what will be the two conditions? Next is we'll see the steps. Okay, that is how you are going to perform the Bresenham algorithm. So there are some 3 to 4 steps that you are going to perform. Step one is what you will take the input of two endpoints. So the starting coordinates and ending coordinates you are going to consider. Next is step two is what you have to take the difference between two endpoints. Okay, so you will be calculating the delta x, or you can also write as dx. And for delta y, you can also compute, you can also write as delta y or d of y. So that's how you will compute the difference between two endpoints. Then step 3, it is the very important step, that is decision parameter. So how you compute? P of k is equal to 2 delta y minus delta x. Okay, so from this particular step 3, you will obtain your decision parameter. So that parameter will be either a negative value, or it will be any positive value or equal to 0. Okay, so based on that particular decision parameter, the step 4 is what you have to compute the next point. Okay, so already the starting point is given to you and you compute the decision parameter. So step 4 is what you have to perform the, you have to compute the next x and y coordinates. So these are the two cases which is already explained to you. So at step 4, you have to check what is the decision parameter, and based on that, you will compute next decision parameter and x and y values. Okay. And step 5. So step 5, this is this steps you are going to perform. Till when are you going to perform? So this, it will be performed till the number of iterations are equal to delta x minus 1 times. Okay, so delta x you are already computing initially. Okay, so delta x you are already computing initially. So delta x minus 1, it is going to give you how many iterations you will require, okay, to obtain the number of points. Okay, so now we'll see the numerical. Okay, so the very first numerical over here, the starting point and ending coordinates are given to you. Starting coordinates are 9 comma 18 and ending coordinates are 14 comma 22. Okay, so for initially you write the starting and ending coordinates. Okay, once you specify those coordinates, the next step is what you have to compute delta x and delta y. Okay, so you compute that delta x and delta y. Formula is already given to you. Now in this, again, as you can see, one slight error is there, wherein I have forgot to mention mod sign over here. So it will be mod xn minus x0. Okay, so that's how you will obtain the uh, integer value. So always you will be obtaining all the integer values only. Okay, so you compute delta x and delta y over here. Next is step 2, you will compute the decision parameter. Okay, so formula is already given to you, which is P of k is equal to 2 delta y minus delta x. So delta y value is how much? It is 4. Okay, so 2 into 4 minus delta x is how much? It is 5. So 2 into 4 minus 5, which is the operation you will perform first. It will be multiplication. Okay, so you multiply and then you subtract. Okay, so 8 minus 5 will give you the P of k value as 3. Okay, so decision parameter is what? You have obtained a positive decision parameter. Okay, so when we say the decision parameter is greater than or equal to 0, that means which case out of these two is satisfied? Case 1 or case 2? Which one is satisfied? Yes, case 2 is satisfied. So when we say case 2 is satisfied, so based on that you are going to apply case 2 का formulas. Okay, so case 2 के लिए जो decision parameter and x and y values are there, that you are going to follow. Okay, so this is how it is computed. So step 3 is what? First you will compute decision parameter p of k plus 1. Now what is the formula in the this particular case? It is p of k plus 2 delta y minus 2 delta x. Okay, so p of k we have already got, which is 3, plus 2 into delta y. So delta y value is how much? It is 4, and delta x value is how much? It is 5. Okay, so simply you put this particular values into the formula, you will get the decision parameter, which is 1. Okay, so for next point, the decision parameter is what? It is going to be 1. So you have to remember this. So when I say decision parameter is 1, so for next particular pixel, again you are going to follow case 2 ka formula. Okay, then x of k plus 1, that is, this is going to be what? New x and y coordinates. So how you are going to obtain? Just by adding 1 into the previous x and y coordinates. So previous x and y coordinates are what? Those are 9 comma 18. Okay, so ye x and y coordinates are previous, so you are simply going to add 1. So that's how you obtain new x and y coordinates. Okay, now this particular step 3, how many times are you going to perform it? Till delta x minus 1. Okay, so delta x value is how much? Delta x value is 5. Okay, so 5 minus 1 times you are going to perform this particular iteration, that is 4. Okay, so when you reach up till the 4th iteration, that is when you are going to reach the ending coordinates. Okay, that is when you are going to reach the ending coordinates. So what are the ending coordinates in the question given to you? It is 14 comma 22. So up till here, so up till here, it is going to be what? It's going to be the 4th iteration. And that's when you are going to stop performing it. Okay. So this entire step you are going to perform 4 times. Okay. 4 more iterations. So directly I have given to you the table. Okay. So initial P of K, okay, initial P of K you are finding out. So initially it was 3, okay. The next P of K, so next P of K, you can consider it as P of K plus 1, okay. Then new X and Y coordinates, okay. So next table values will be what? X of K plus 1, that is, this is new x and y coordinates, and y of k plus 1, which is going to be what? New y of y coordinate values. Now initially x and y coordinate value was how much? It was 9 comma 18, which is already given in the question. So you are simply going to leave it over there, and from the next iteration you are going to start performing it. Okay, so P of K value initially is 3. When you computed next P of K value, you obtained as 1. The next X and Y coordinate that you have obtained over here, from this slide you will already get it, which is 10 comma 19. So you write it in the second row. Okay, that is going to be your X and Y coordinate, new X and Y coordinate, which is 10 comma 9. Now you go on to the second column. You go on to the second column, which is how much? Which is nothing but P of K plus 1. Now in P of K plus 1, what is the the next decision parameter that we had already got? It was 1. Okay, it was 1, which is what? 1 is nothing but it's a positive decision parameter. Okay, it is a positive decision parameter. So when I say it is positive decision parameter, again you are going to compute the case 2 formulas. Okay, you will again in this situation the case 2 condition is satisfied. So that means again you will compute the next decision parameter, and again next x and y coordinates are performed. Okay, so you compute it, okay, and go up till 4 iteration. Fourth iteration you will obtain how? Delta x minus 1. Okay, so that's how you will get all the points and you plot it over here. So this is the output for the previous problem. Any doubt so far? Any doubt? Okay, take care. Similarly, the next problem is also given. Okay, so this in this also the starting and ending coordinates are given to you. The same steps you are going to perform over here. Okay, starting and ending coordinate you mention. Okay, once you mention starting and ending coordinates, step one would be what? You compute delta x and delta y. Okay. Whatever error that you can see over here, also I have not mentioned mod. So while posting in Google Classroom, I will rectify this PPT and convert it into PDF, and then I will post it in the Google Classroom. Okay. So you compute delta x and delta y over here. Again, you compute decision parameter. So just for apply the formula over here, which is 2 delta y minus delta x. Okay. So over here, again, as you can see, p of k value is how much? It is 6. So 6 is what? It is greater than 0. So you will perform case 2. Okay. So case 2 is performed over here. Based on that, you are going to apply the formulas. Okay. So similarly, you have obtained the next decision parameter, which is how much? It is 2. Okay, so next decision parameter is what? It is 2. So again, in this case 2 is satisfied. Okay, case 2 condition is satisfied. Again, you are going to perform the case 2 condition. The points that will lie between the starting and ending coordinates. Okay, and this is going to be the output. Okay, so whatever points you have obtained, you will simply plot it on the graph. Okay, now over here, this is the numerical that I have given to you for solving. It's so not a very big problem. Okay, 1 comma 1 and ending point is 8 comma 5. Okay, so you'll be solving it by today only. So next is advantages and disadvantages. So we'll see this point and then we will stop for today. So advantage, now as you have seen this algorithm, okay, you might have observed that it's a very easy to implement algorithm. Not much of the complex operation you're performing over here. Okay, simple addition, subtraction, and multiplication you perform it. So it's easier to implement. Next is it is faster as compared to DDA because it does not involve floating point calculation like DDA algorithm. Now you have already solved DDA algorithm. Now while solving DDA algorithm, you might have observed that you have obtained somewhere floating point operation, and those floating point operation you are converting to the nearest integer values. Okay, so this floating point operation you do not obtain in Bresenham algorithm. Okay, Bresenham algorithm does not give you floating point calculation, so that is why it is much more faster as compared to DDA, because you do not have to perform any conversion over here from floating to integer. Okay, then the points generated by this algorithm are more accurate than DDA algorithm. So yes, you obtain here integer values. So that is why it is much more accurate and efficient as compared to the previous algorithm. Next is it uses fixed points only. So it uses only integer values. Okay. So there is no fluctuation over here. Now, as it uses only fixed point, what will be the another advantage over here? The line generated would would be slightly more accurate as compared to DDA algorithm. Okay. Then it can be implemented using hardware because it uses simple mathematical operations. So this is one algorithm which can be easily implemented using hardware. Now in DDA algorithm, it used to get implemented only with the help of software. So hardware implementation was not possible for DDA algorithm, but it is possible for Bresenham algorithm. Okay, because it uses simple mathematical operations like integer, subtraction, and multiplication. Okay, so these are the advantages. Next is disadvantage. So disadvantage over here is, though it improves accuracy of generated points, but still the resulted line is not smooth. So as you can see in the diagram, the lines that is obtained over here is still not a smooth line. Okay, it gives you like a zigzag structure, line structure. So those zigzag lines, or you can say staircase type lines, are